It's a pleasure to be here. Show of hands, how many people are Octane users in this audience? A good amount. So today's talk is really going to cover some of the developments that we've done over the last year with Octane, but also look forward to something I'm very passionate about. One of the reasons why I started OTOY was to help build the technology that would get us to the Star Trek holodeck. And our mission is to democratize content creation and rendering and prepare for that future. So we started on this journey actually more than 10 years ago. But if you look back 10 years at what we were working on, a lot of our team members used to work at ICT, the graphics lab. That's where Lightstage and some of our other technology started from. And those early days really focused on how do we get holographic capture and displays and rendering to work. And so you're seeing here an example from 10 years ago with a very simple volumetric capture running on a spinning mirror. That spinning mirror is actually generating a light field, and it's a volumetric pseudo-holographic surface. It's just, the concern then was you have to have a spinning mirror, it's dangerous, it's expensive, it's not really practical, but it was insanely cool. And 10 years later, the technology to make something like this truly holographic and emissive, in other words, having a white light emissive holographic display, is within our reach. So for us, we want to prepare the tool chain and the content workflow that makes something like this viable. The Star Trek holodeck was, of course, hundreds of years in the future. However, like many things in the future on Star Trek, Captain Picard's iPad turned into a real device, right? 15 years later. We think that's going to be the case with holographic displays as well. And as a company, we focused on 3 areas to productize the technology that we've been building: capture, render, and stream. And on the capture side, a lot of people know Lightstage. Lightstage just won its 2nd Academy Award this year. It's used for digital doubles and also video games. There's assets for Unreal Paragon that were done with Lightstage. And Lightstage capture is not just a point cloud with color. It includes normals. It's very precise. It includes the reflectance field. And with the reflectance field, you don't need shaders. You can just relight an object from example, this example here is with a light probe pretty easily. We've also partnered with Facebook to build light field cameras, and now that is being manifested in the red manifold camera that is coming out this year. And we partnered with Facebook to provide a whole tool chain that goes into the cloud and provides plugins for all the different tools out there, like Foundry's Nuke, Camera VR, and of course things like Unity and After Effects. We have plugins for each of these, and we think that the future of volumetric capture and video is very bright. It just needs these cameras to become more inexpensive and maybe even consumer grade. On the rendering side, we have Octane. Octane's been out now for 10 years. We're very proud of the work that's being done with it. Obviously, beautiful scenes like this from Westworld and The Crown. Really, a lot of opening titles for shows for television and even now movies are done in Octane, all on the GPU, spectrally correct rendering, super fast. And that technology really evolved over the last decade. From very sort of humble roots where we were just trying to do image-based, architectural renderings, now to full production rendering. And we're seeing every production renderer out there tackle GPU rendering in some form or another. Marvel's Ant-Man and the Wasp rendered in Octane, the 2-minute title sequence by Elastic. It's just awesome. And 3 years ago, we announced a partnership with Unity. Octane is free within Unity. Anyone with the Unity license can use it. It's integrated. It's updated. And that really is part of our mission of getting everyone in the world, this kind of rendering power. So these last 10 years, we've had these incremental steps every 2 years, roughly, where right about now, we're getting to the point where, okay, we've done this Unity integration. We also have Unreal. What's next? Holographic display panels empowered by AI to make this thing work are what's next for us. Those holographic panels are 32K by 32K per square foot. It's a gigapixel. It's crazy. And so our work with Octane is really about accelerating everything towards that real-time gigapixel 60 hertz workflow. And we've introduced a lot of features over the last year. Brigade inside of Octane is 10 to 100 times faster SIGGRAPH updates. We have AI lighting and denoising, out-of-core geometry, Vectron and Spectron. So I'll quickly go through these features. This is Brigade Engine with Octane running inside of Unity. You can play games, fully path-traced games, which is pretty cool. And AI denoising, awesome. I mean, we basically, instead of a 2-minute render, you've got a 1-second render. It works through glass and many different layers and surfaces. So it's pretty great. It's different than the optics denoiser. It's a little bit slower, not much, as you can see. It's still pretty instantaneous, but it's great. And we're these are the things that we need to get to 100x render speeds at this quality. And it's not just about AI and ray tracing hardware. It's also, for example, being able to do very fast volumetrics and still keep Octane's unbiased, really high-quality rendering active. And also looking towards fully procedural elements in the scene. We've extended open shader language to support things like implicit surfaces. These fractal objects you're seeing there are all defined in OSL. Same thing with the lights. And also building an ecosystem where you can take data from basically 26 different tools, some of which are free, like Blender and Unity and Unreal, and interchange these assets. So even with our Unreal integration and Unity, you can take assets from other tools, bring them into these other engines. And with Unity in particular, there's close to 7 million Unity developers. So we want to see this kind of asset interchange flow freely. You can take complete scenes, all the lighting information, and bring them into these other engines. And Unity is essentially has the same feature set as Unreal does now. This is an ORBX file exported from 3D Studio Max, imported into the Unreal viewport, and it looks perfect. And you can still add and move objects around in the Unreal viewport and SIGGRAPH. And it looks great. And you can also take existing Unreal or Unity scenes and up-res them to Octane quality with the free integrations we have. And we're also adding things like OpenVDB support and other things right into these game engine SIGGRAPHs. And that's important because we think that the content creation tools of the future may not be purely DCC applications. It might be game engines that are making the movies and TV shows of tomorrow. So we're betting on all of those things at once. We also have a lot of great features that we've rolled out this year for Octane 2019. So Octane 2019.1 came out in March. It's now just about stable. The volumetric denoiser is 3 times faster. We've added layered materials, which is pretty great. It allows you to create very complex layered materials that you would normally have to write more complex shaders for. It's really simple to do it in a node editor. And that allows us to do very complex layers and systems like you can do specular roughness. You don't have to actually cheat that or do it in a biased way. It just works. So we're seeing a lot of artists use this to do really complex material systems. You can rebuild other material types with the layered materials. So Unreal's materials, including the new layer materials they're adding, would work with this system. And it's fully interactive, all works in the viewport. And it's pretty great. And of course, like everything else in Octane, it is unbiased, it's physically correct. There's no wrong way to render things in Octane. It just kind of works out of the box. We've also added OSL procedural displacement, which is important. And that's something that we didn't have before. We had it only working with baked textures. So that is now inside of Octane. And it also is accelerated for RTX. So you can use open shader language to create these awesome displacements. And we're going to be improving that over the next year as well. This first release in 2019, though, was a big step up from what we had before. And we've also allowed you to create open shader language for volumes and procedurals. So you can now create totally live shaders that are rendering on the GPU and updating and changing the way that volumes work. And that's really a cool effect. We've just recently also introduced OSL volume displacement. We have new rounded edges shader, which I think is a big improvement in Octane. And we've also been adding new primitives for different lighting types, and I'll show a little bit more on that later. We've also allowed you to use OSL to change the way the camera works, so you can create really fine-grained rolling shutter effects and even more procedural setups that are tuned for new types of displays and projections that are difficult to do with a traditional, baked camera model. We've also changed the post-processing system in Octane, and just recently, users now have this in their hands. We also have AI supersampling or upsampling, which allows you to basically, I'm skipping here on and off, essentially render at 1/4 the resolution and get the same results, at least for a large portion of scenes, and that's a pretty big step forward. Octane 2019.2 just came out last night, the first test release. So this is already in users' hands, and we're seeing some great things. We've added random walk. It's spectrally correct, like the rest of Octane. So random walk is it's a really interesting way of doing subsurface scattering for things like skin and also things like wax. It has really high quality, and all of the other subsurface effects that we've always had in Octane are still there. This is a new mode that we've added, and it's implemented perfectly in this release, I think. We also have a new hair material that's also spectrally rendered. It looks beautiful. We've just seen some great renders from last night's build show up on Twitter, so people are already doing really great stuff with it. And we've also added Vectron volumes, so you can define an entire volume now completely in OSL, and this, I think, is opening the box to a ton of creative features. These are really cool effects. So we're also looking over the next year to add many other third-party formats to Octane. I mean, OSL trace sets are really fundamental. Open color I/O is critically important. A lot of the things you're seeing at the show at SIGGRAPH this year are about USD and Hydra. We're deeply involved in integrating that into Octane as well. And we're also looking at MDL materials and, very importantly, having point attributes stored in VDBs out of Houdini supported fully in Octane. So we actually have a fully working Hydra backend of Octane. It's basically able to load USD and USDZ files, which look great. We're also adding a couple of other effects that a lot of users have asked for, such as basically instantaneous fast fog, and also extending Spectra to support things like fluorescence and polarization, kind of fundamentally needed to get perfectly physically correct rendering all the way to the end of the road. And of course, non-photorealistic effects are also important. This is a popular feature that we've been developing that people have asked for, which is ray-traced anime edges. And we also have something new that we're developing for Octane next year called Sculptron. So all of those Vectron shapes, they're kind of hard to author in some of the DCC tools, so we built our own sculpting and brush tool that you can see here, and that allows you to create in time and space anything that you want using Vectron and Spectron shapes and brushes. So Sculptron is already maybe about 50% of the way there, and we're very excited to have an open beta of that sometime by either the end of this year or early next year. We've also been working on getting Mac support. Some of you may have seen the work that we're doing with Metal, but I think the very first thing that we're going to solve for a lot of users is the ability to run Octane headlessly. So this is showing basically the portion of Octane that's running today on Metal, which is the tone mapping. And there's a CUDA device over the network that's actually sending the viewport down, and it works really great. I mean, I'm able to run this on my MacBook without any problems. So a big, huge part of our future is RTX. I want to talk about that with pretty much the rest of the time we have. We released a preview of RTX. It gets up to 7.5 times faster speed-ups on certain scenes, like the Octane 3 splash screen. The version that we released last night, Octane 2019.2, is getting 2 times the speed-up in real-world production scenes, like this one from Big Lazy Robot, Aaron Corbett's Harvest scene. These are really amazing speed-ups, and that's just within Octane as it is today. But going forward, we want to develop a whole new rendering kernel based around real-time, leveraging RTX, getting all that speed. And we think we can get to noise-free rendering at 4K at 60 hertz on 1 or 2 GPUs. This is our first efforts around this, which is to basically build a whole new rendering kernel that is noise-free at 60 hertz, new sampling algorithms. If you compare this to the way that Octane's working, so Octane's on the left, the Brigade kernel, same exact scene running with an Octane on the right, huge difference in terms of actually the speed to sample a noise-free render. And if you take that to its logical conclusion, then you end up with something like this, where we can actually start to get, and this is just running on a single 2080, basically close to noise-free rendering with very complex scenes in real time. And that's not just for statically lit environments, it's for completely novel viewpoints and for completely novel lighting conditions. So the Spectra and area lights inside of Brigade mode are actually super fast and clean up super quickly. And so I'm showing this both with basically filtering running over the noise and then with no filtering, and it's looking pretty great in both cases. So taking production scenes through the Brigade kernel, they look great. Again, if you're just running ambient occlusion, it's basically noise-free on a single GPU without any issues. And again, with the Brigade kernel running, you can get pretty much noise-free renders in these very complex scenes. And we're even bringing this very same tech to iOS. So you can run this inside of ARKit, which we're doing here. It looks awesome. And we want to do full production scenes that you can bring into AR with Brigade kernel and have it work. Obviously, if you're running it on a on RTX Quadro card, it can drive 4K or even 8K displays nearly in real time, and that's kind of fundamental to our plan for getting 32K displays to work holographically. This is also showing another example of ARKit. And we also, because we have all the material properties, we want to be able to integrate this perfectly with the real world. So this is our last year's SIGGRAPH video wall with an object running in Octane X, which is our metal version of Octane, and it's looking great. It really integrates beautifully with the scene. So the future isn't just rendering these things beautifully in AR; it's about getting the integration in this and into the real world to look this good. So we see the future as being something that sort of moves from the desktop to being done on mobile and even tablets. There still may be computing that's done on the cloud, though, so obviously there's a lot of these pieces that come together in these interesting ways. And to that end, we're building Render. It is our decentralized cloud rendering service. We have about 14,000 GPUs on the service. It's just getting out of beta, and we think it's going to be a game changer for production rendering and also for rendering really complex offline data sets such as light fields and holographic content that you would want to drive on future and emerging display technologies. I'm going to touch briefly on sort of production rendering for holographic panels. This is basically a 2D light field render out of Octane, and we can extend that spatially to 6 planar light fields, which can then be brought together, and you can extend that over space and time to give you essentially the holodeck. Now, this is all basically pre-computed, 40 megabytes per cubic light field. But we don't have to pre-compute it. We have the choice of going from full production unbiased path tracing to the brigade kernel to this, and we can mix those together any way that we want. And we can stream those from the cloud. So this is an example streaming a light field with all of the rendering done in the cloud, but it's synchronized. This is over 4G, not even over 5G, to a phone in AR, and it looks pretty good. We did experiments for years, really, with this technology to make sure it could work in AR, and it does. And it's a great starting point for cracking this problem. The last thing I want to show is where things are heading next in the next decade. So we announced at the end of last year a partnership with a company called Lightfill Lab. They're the company that's building these 32K by 32K light-filled panels. I've seen them with my own eyes. They're incredible. And the next generation of these panels, they're actually 2 feet by 2 feet. You can bridge them together like the Samsung CS video walls. And the next gen are going to actually have touch. And probably the first use case will be large events and venues like concerts. But eventually, these things will become cheaper, and they'll be mass-produced, and you'll see them on tables. And you won't need to have a laptop or a TV or an iPad. You'll just have a holographic surface that you can touch that'll be your interface for many, many things. You will not need AR and VR glasses when this becomes commoditized. And of course, if you have many, many, many millions of dollars, you can take enough of these 2 foot by 2 foot panels and cover your floor, your ceilings, your walls with it, and end up with a Star Trek holodeck. So, with that in mind, we've been working for a couple of years now on figuring out how we're going to basically test and build content for this kind of hardware. And we started by just basically using things like eye tracking to see if our light field renders could actually be tracked, and we could get a sense of it. If you close one eye with this system we built, you actually do get something akin to a holographic display that is effectively glasses-free. But what we decided upon, and we showed last year and we're showing again this year, this is our Lightfield Lab holographic display simulator. So it takes the light field renders that we're doing, it tracks your head with a cap and a Vive tracker, and you have stereo shutter glasses, but it gives you a very close approximation of what it feels like to look at a true holographic display panel. It's actually surprisingly compelling, hard to capture on video, but it looks great. And it's by appointment only, but if you have time at the show, please stop by and we'll see if we can fit you in for a demo. This particular scene is one that we've also loaded on the actual true holographic display up at Lightfield Lab at Santa Clara. And I keep talking about how this looks on the true display. The true display, holographic display, actually has a floor at the surface, and that coat hanger and that door are actually floating above it. It looks like nothing I've ever seen before. It looks real, and it's not stereo. It's not left and right eye. It's not a bunch of lenticular arrays. It's just something incredible. That's what basically a gigapixel per square foot gets you, and there's nothing quite like it. So it's really the future that I want to see, and I think as people start to see these things come to market, they'll appreciate how big it is. It's going to be very similar, I think, to the DK1. When people put that on, and I was one of those people, they got why VR could be so huge and so important. And I think this is a logical endpoint for VR and AR, honestly. I mean, if you don't have to wear glasses, even if it's not quite the same experience as when you're completely out there with a pair of glasses on, it's still frictionless. And as we've seen with 3D TVs, if you don't, if you even put people, if you have people wear even a pair of polarized glasses, that's a point of friction that can kill an entire industry. So having something that's glasses-free, that's volumetric, really, really, really compelling. And again, sort of how these panels work, the 6x4-inch ones that are working today, you can stitch those together. In fact, at Lightfield Lab, they've actually started to put two and more of these together. And the more you stitch together, the further out you can project the holographic objects. And that goes all the way to infinity. So you can eventually imagine buildings, instead of having LED video walls at LAX, you can actually have true holographic portals. And it will look real. It will look like you're looking out of a window, or maybe even better, looking at reality. It's fantastic technology, and ultimately, we are so close to this becoming real that the holodeck isn't, it's not even decades away. It's this decade. It might be expensive for the first half of this decade, but by the end of it, I don't think it will be. I think it'll be, the cost of a very high-end home theater system to get something like this running in your home. So that is my talk just within the 20 minutes, and I think we've got a little time. We're doing a raffle, and then we're doing a Q&A, I believe. So thank you very much, everyone.